Ever wonder how some businesses just seem to know when a process is running smoothly versus when it's about to go completely off the rails? Well, today, we're going to dive into one of the most powerful tools for actually seeing the story behind the data, the control chart. Think about it. It doesn't matter if you're making coffee, writing software, or manufacturing car parts. At the heart of any process, there's a really big question. Is what we're doing stable and consistent, or is it just totally unpredictable? And that, right there, is the core problem that control charts were invented to solve.
So here's the deal. No two things are ever exactly alike. Ever. Every single process, from a massive factory assembly line all the way down to your daily commute, has some natural variation built into it. And that's a huge challenge when you're trying to manage for quality.
And this is a really crucial mindset shift. The goal is not to achieve some impossible, perfect world with zero variation. Nope. The goal is to understand it. It's all about knowing which little ups and downs are just normal, everyday static, and which ones are like a giant flashing red light telling you, hey, something important just changed. You know, this whole idea of empowering people to understand variation, it actually takes us to the work of a Japanese professor named Kaoru Ishikawa. Back in post-war Japan, he had this incredible idea that quality control shouldn't be some complicated science that only engineers could understand. He believed everyone could be given simple visual tools to help solve problems. So he came up with what we now call the 7 basic tools of quality. They're just a handful of graphical techniques to help figure out what's going wrong. And the one we're focused on, the control chart, is a really key part of this whole toolkit. Think of it like this. A tool like a Pareto chart might tell you what your biggest problem is, but the control chart, it tells you when you need to act. And here's the really wild part. Ishikawa claimed that with just these 7 simple tools, you could solve the vast majority, we're talking up to 95% of all quality-related problems. I mean, just think about that. That's an amazing testament to how powerful these simple ideas really are. Okay, so let's zoom in on what a lot of people think is the most powerful of all 7 tools. And why is that? Well, because most of the other tools, they just give you a snapshot, a single picture in time. The control chart, it gives you the whole movie. So, what is this thing exactly? Well, a control chart, sometimes you'll hear it called a Shewhart chart after its inventor, Walter Shewhart. At its heart, it's just a graph. That's it. All it does is plot your data in the order that it happened, so you can literally watch how your process behaves over time. All right, so here's what one actually looks like. I know at first glance, it might just seem like a bunch of dots on a line graph, but trust me, this chart is telling a whole story. Let's break down this part so you can see what I mean. Every single control chart has 3 key pieces. First, you've got your data points, right? The little dots that are plotted over time. Simple enough. Second, you have that solid setter line, which is just the historical average of your process. But third, and this is where the magic really happens, you calculate an upper control limit and a lower control limit. And these 2 lines, they define the expected, normal range of variation for your specific process. So why are those 2 lines, the control limits, so important? What's the big deal? Well, it's because they let the chart do its most critical job, separating the important stuff, the signals, from all the random background noise.
See, in any process, there are 2 kinds of variation. The first is common cause variation. This is just the normal, predictable noise that's always going to be there in a stable system. And you know what the right thing to do about it is? Absolutely nothing. Seriously, leave it alone. If you start tinkering with it, you'll probably just make things worse. But then there's special cause variation. This is the signal. This is an unpredictable change that happened because of some new, unexpected event. And for this, you have to investigate right away.
Okay, let's go back to our chart. See those couple of points that fall way outside the dashed lines? Those are the signals. That's not just random chance. The chart is basically screaming at you that something unusual, something statistically significant, happened at those specific moments.
Think of it like this. A point outside the limits is a flag. It's an objective, data-driven sign that your process is now out of control. Now, that sounds pretty dramatic, but it doesn't mean everything's broken. It just means some unpredictable element has shown up, and you need to figure out what caused it. Was it a new batch of material? Is a machine out of calibration? Did an operator try a new technique? The chart points you exactly where to start looking.
So why do we go through all this trouble? Because understanding this difference between signal and noise fundamentally changes how you manage, well, anything. It takes you from just guessing to making smart, data-driven decisions. Once a process is stable and in control, everything changes. You can actually predict, with some confidence, its future performance. You can tell if it's consistent, and crucially, it gives you the confidence to know when you need to step in and fix a real problem, and just as importantly, when you need to keep your hands off and just let the process run.
So if you only remember one thing from all of this, let it be this. Control charts give you the wisdom to stop overreacting to all the little ups and downs, the noise, and start focusing your energy on the things that actually matter, the signals. It's a tool that takes a confusing, boring table of numbers and turns it into a clear, visual guide for what to do next. It tells you what to investigate, what to improve, and what to just leave alone.
And that kind of leaves us with a final question for you to think about. In your own work, in your own processes, what important signals might you be missing right now simply because they're lost in all the noise?